Okay, everyone, it's about time to get started. Thank you all for coming. My name's Steve Alviti. I am part of Bel Air Finishing Corporation. I'm the second generation of the company. We're now in our third generation. We've been around for quite a while, and our expertise now that we concentrate on is mass finishing, post-processing, which is another word for mass finishing in the 3D world, tool honing, all the supplies for tumbling, cleaning, and blasting that go along with the process at the end of you guys making a particular part, whether you make it out of metal, wood, plastic. We're at the back end. We customize finishing systems. We concentrate, well, let's see. Ooh. Okay. The business was started in 1966. My father was the founder. Like I said, I'm second generation. He was part of the Navy. He grew up in tool making, machining, tool and die processing. He worked until he was 93 at his workbench. He went down and that was it, and everybody was happy about that, to be honest with you. So I'm second generation. Through the course of our business, we were involved in all sorts of manufacturing. So we're at the back end of manufacturing, but our background has everything to do with front-end manufacturing from the beginning. So we've been in tool and die work, we've been in stamping work, we've been in machining work, die casting, molding. So that's where our background is. So anytime we look at a finishing operation, we look at it from the aspect of, if I was making that part, what would I do? What would be my options? What would I do? So this back end of manufacturing brings us across all industries. And it's really cool because we get to see a lot of different products made different ways. And all of this is our background that helps people to develop a finishing process. So before I get started, I like to know my audience. So how many people out there are involved in 3D printing? And that's your issue, okay? And then how about traditional machine parts? Traditional machine parts, that's about the right average. How many of you are currently mass finishing? Which is another thing we're going to get to, is the terminology is kind of all over the place. So we're gonna set the stage to define some of the terminology that we're going to be talking about. So we're going to do that to have some kind of conformity in what we're presenting. So in the topic that you guys saw in the advertisements, it says about archaic processing and trying to bring that to modernize. So this slide shows you how archaic I am. So I've been doing this for a long time, and it predates Photoshop and AutoCAD and AutoCAM and Adobe. So we're going to bring, if you want to talk about archaic, I'm the guy to talk to. So we're going to define hand finishing as the most archaic, we'll call it right now. So hand finishing is using your hand and exerting a force through a tool onto a workpiece. So we're calling that hand finishing, right? The next step of this hand finishing operation was to take it to another term called mass finishing. And mass finishing replaced the hand with a machine, and that machine is generating a force, and we replace the tool with something that we call media right now. And then we exert the force through the through the media into a bunch of pieces or a mass of pieces, hence the name mass finishing. So that's where we're coming from. And one of the difficult parts of this presentation was that we have a conundrum. And the conundrum is mass finishing and automation and what those words mean to different people. So I gave a presentation to my engineering college to a bunch of students. And I tell this story because it kind of fits in with what we're doing. So, okay. Sorry about this. Okay, so I have 100 students in the audience, and I asked them, how many of you can get on your computer on SolidWorks or any other design and design this part? And they all raise their hand. Yes, they can do that. So then I bring up this slide and say, how many of you can take that design work that you did and put it into a 3D printer or a 5-axis machining center and actually make the part? So out of the 100, I don't know, maybe 20 of them raise their hand. Yes, I can do that, okay? So then I bring up another slide and I say, how many of you, of the 20 that actually made this piece XYZ out of whatever material, how many of you know that there's 72 places on this part that will not allow it to function the way you designed it to function? And they all have a blank look on their face, and nobody raises their hand. So the conundrum, when you take this and then you go to a manufacturing cell and you're designing and making something, what happens is you're making this product on maybe a $500,000 machine, maybe, and it's automated and it comes out, and then what happens? It goes to a bench with a bunch of people working at benches with these pieces that came out automatically, and they're doing them by hand. And if you look at this was probably a slide from 10, 15 years ago, and you look at the average age of the people on the bench doing this work, and you see that we're running out of talent to do manufacturing this way. So that's the kind of the definition of archaic. So my problem here in this presentation, to make sure I can help people, is that these are the kind of things that you have to think about when you're making a product, as opposed to after you've made it already. So these are the different words and terminologies that we use in this back end of manufacturing. And this is what we get a lot of times from modern day engineers. We get the request to automate that process. So they want to take this and we want to automate that. So when we talk about automation, I say, well, how many of you out there would like to take a bunch of parts that you make in a tray and put them somewhere, press a button, and have them come out of a tray ready to ship? How many of you want to do that? Yeah? You want to do that. Okay, so how many of you have $1 million to put into this one process to get these things cleaned and deburred at the end? Anybody? Okay, you're my customer right there. I want to see you after, okay? All right, so now what this leads me to is that what does automation mean to you, right? And my definition for you for this presentation is to say that we're going to replace some kind of hand labor operation with a process, or some other mass finishing operation, and we can bring it to another degree of automation. So that's the presentation, and my goal is for all of you to come out here with maybe one tool to put in your tool belt to say when you're dealing with one of these processes that you're looking for, that you have a tool that you got from this presentation that may strike a question in your mind. Hey, I saw that. Maybe this is a tool for me. So my ultimate goal is to give you a tool to put in your tool belt for this solution of post manufacturing. And so, for the purpose of trying to put everything in perspective, I started off with hand finishing. And I said, okay, so there's ways to automate hand finishing, and that would be to do mass finishing, right? And there's a bunch of ways to do mass finishing. So that's the low level of automation, right? Then on the other end of it, now there's more aggressive, more expensive, more complicated ways to automate, and that's using robotics, CNC, vapor honing, and also combinations of mass finishing and robotics. So we're going to go down these two paths, and I'm going to just show you a bunch of clips. I'm going to show you all these tools and clips doing things, and then we'll get to some specific in the field solutions, and hopefully you'll have some ideas that you'll have in your tool belt. And at the end, we'll have some questions. If you want to make notes, we'll have some questions at the end. So that's the procedure, right? So okay. All right, let's see about this. There we go. Okay. So this happens to be a single operation with many types of parts. Short setup time, a small cellular operation, and you're taking a robot, you're coming from a pallet, and you can do whatever kind of an operation that you can with it to duplicate what you're doing by hand, right? So this is a rack of parts go in, press a button, walk away, and the machine is going to do its operation. So that's called single operation robotics. The next type is then taking that and going with robotics. These robots are each one is doing an individual operation that hand person would be doing. And now you see the type of, so we got first stage is doing one belt, second stage is doing another belt, third stage is doing another belt. So this is a complete, totally operated, automated cell, right? And you can only imagine the difference in the cost and the setup and the real estate it takes up. So this is totally robotic finish. Now this is taking a CNC, essentially a router with a deburring tool, and this router is set to go in the direction around this part and do a 45 chamfer all around the part. Then the part rotates, and then you do the same thing. So this is another way of totally automating the process. Ooh, sorry. So now another way of automating by CNC method is now taking here's your part, you're putting it on an arbor, and you're rotating the part, and then you have a wheel, and that wheel is CNC programmed to go the direction that it needs to do that hand polishing operation. And again, these are all just short clips to give you a general idea, right? And again, this is high volume. This company does these parts day in and day out, year in and year out by the thousands. Another method is making a combination of some type of robotic action with a mass finishing action. So we have a part, we're fixturing it, and we're using hydraulics to move the part through we'll call it a form of a tumbling operation. Another way of automating, so this is automating a blasting operation by taking a rotating basket, putting a bunch of pieces in a basket, pressing a button, and now we're honing and cleaning these parts in a mass, so to speak. So that's called that's vapor honing. Then we can get and take the robot, and we can combine a robot also with a type of mass finishing operation. And we use the robot to manipulate the part through this we'll call it a dry polishing belt, right? It's actually the mass of media traveling across the surface, and we pick and place and orientate it. And when we're doing robotics like this, you see the difference between this robot and the one that was in that multiple cell. The size of the robot is really, you have to depend on what kind of pressure and forces that you have in the finishing operation. You'll notice that this is done in a dry operation. If you went to a wet operation and you had a high torque on the part, you'd have to triple or quadruple the size of the robot. So there goes the expense, up, and up. So this is another example of a cutting tool with the edge being honed, going into a process, tumbling. So we went down, just generally speaking, we went down this right side and showed you different ways to automate based on using robotics and CNC, right? So that's kind of that's the upper end. So now we'll go down the left side and say these are mass finishing ways that are simpler, less expensive usually to automate processes. So here's a tumbling piece of equipment that was manufactured for depowdering a 3D printed casting model. And so this was printed, come out of a powder bed, and then a bench worker had actually a toothbrush and cleaned this part totally of the powder, and it was hours of work. So automation is taking the part and putting it in a tumbler, and then using the correct combination in a tumbler, and then cleaning the part. So now it went from hours of operation to minutes of operation to load and unload a part. So am I on the right track? Is that a form of automation for how you guys look at it out there? That's a way of automating, right? Okay, so then we go to vibratory finishing. So again, this is taking one part that they were grinding by hand and now putting a bunch of parts into a vibratory finisher. Different sizes, and now you got a person that loads and unloads a batch instead of sitting at a bench and trying to grind the surface. This is another form of vibratory finishing where this is called a trough machine, and parts go in one end, and it's a short cycle, and they go in and they throughput and they come out one end. So you're putting parts in as you manufacture them, they go through the process, they come out the other end, media returns up to the top and continues a loop in this process. So that's called a continuous tub vibe. Another means of honing surfaces is this machine pushes and pulls an abrasive putty over a part surface or through internal channels. So we're taking the handwork of smoothing out a surface, and we're passing parts like this internally, these surfaces, through these holes, across these blades. We're taking the handwork out of it by extruding a putty through the part, and we're honing the surface. So that's another method. Another method is taking vibratory finishing, which we call 1G force of finishing, and we now add centrifugal force and high energy, and we're able to reduce time cycle, make one flow through processes, and lean out product. We also improve the productivity of what a vibe would do by being able to use smaller media at a higher energy. So that's another method. This is a burnishing operation showing parts going in as a mass and then parts coming out as a mass. That's doing a burnishing or a polishing operation. Next, we show automation by vertical drag finisher. So parts are loaded on a rack. They're rotated through a tub of abrasive or polishing media. This particular machine shows 40 parts being processed at one time, and maybe with about a 5 or 10 minute loading process. So that's the labor involved. So as well as taking the labor out, now we're also reducing our skill pool that we need to be able to do this. Now it's a load, mount, press a button, and we're doing an operation. Another thing I'd like to also mention is that sometimes in a process, the process after a process, so you're using a media and you're using a type of a machine, and you get into a process where your media and your parts are the same. And so that's another automation of the automation. So we're separating parts automatically here. Parts coming out on the left and media coming out on the right. So that's another form of automation, another tool to put in your tool belt, right? So with that said, those are the general tools that we talk about when we're going from archaic to whatever kind of improvement that we're making in automation. So now I'll go through a couple of samples, how we get started on a project to go through it, and I'll show you some real samples that are happening, real production products. So there's a 5-step process that we use for figuring out how to automate. And we'll analyze a part. Then we develop a range of automation options, right? And then the trick is to match one of those with what we call your company culture. How many parts are you making? What kind of skilled labor do you have? What are you trying to replace? And then we try to choose one of those methods that we showed up there to automate the process. And then we go into a lab and we take those processes, use the parts, develop an actual process, and then present a system to solve that equation, right? So that's the general process. So here is an example of a coin blank. This is for the mint. And this blank on the left goes through 5 or 6 processes: blanking, rimming, heat treating, and it needs to be polished before it goes to a mint to get struck as an actual coin. So here is a machine, a vibratory machine, made for throughput. So here is a 1-pass machine. It's a short process. The parts go in one end and come out the other end. It's about maybe a piece every second. Goes through this machine and comes out the other end. So simple form of automation. And that's the resulting part on the end. This is another part. This is a pill punch used to form pills. And during its process, during its life, it needs the end repolished as a regular maintenance because it gets gummed up, right? So there are several ways to do this. So here's a simple method. So we're racking the parts here. They're getting racked. Special rack design for them. The parts go into a drag finisher. They're pushed through a polishing, and then they're unracked and they're done. So that's one method. We show a second method. Now a company has more productivity than they can handle. They want to get more automated, so now they go to inclusion of robots with the mass finishing operation. So now that's two different, entirely different ways to automate. And here's the finished end of the part. You can see it's not just the cylindrical part. It's also what's stamping on the end, the polishing on the end. And that's what the robot helps with. This is another interesting project we worked on. So this is Pokemon dice. So on the left is the part as it's molded. This company wanted to take production back to the US from China, and they needed a more automated way to fill in the dots, essentially. So where labor is very inexpensive, each one of these dots is put in with a needle of paint. We couldn't do that in the States, so we had to figure out a way to automate it. So we took a batch of the parts and we put them into this basket, and we dunk the basket into paint, and we spin it and dry it. And while we're doing that, we set up a little bit of an automated cell for it. The parts are dipped in, they're spun, they come out in a batch, which it's not shown here, come out in a batch. They get dumped and they get reloaded for the next batch. So now what happens is the part comes out full of paint, all filled in. We go into a vibratory operation. We abrade the rest of the paint off of it and leave the paint in the parts, and now we have a completed dice. All right, it's completed anyhow. So that's another automation process. So this one's an interesting story. We'll show 3 different technologies, but this happened about maybe 15 years ago. One of the major manufacturers, this is a knee implant. So anybody of you that are having little problems with their knees, you may get one of these one day. Hopefully it'll be finished by a Bel Air machine, because those are the best. So the customer came to us and they were hand finishing. And they decided that hand finishing wasn't a way for them to go. So they went to robotic finishing. And when they went to robotic finishing, their cell mimicked what a person by hand was doing. So you had one robot, he was going to one belt, another robot, and that same robot having the piece and going to another belt and going to another belt. And what they figured out in the end is that the robot didn't do any more than a person would do. And furthermore, when you look into this, the robot is manipulating that part in a pattern, in a CNC pattern that's programmed, right? So the parts would eventually get done, and then what would happen is they'd come back to the end, and guess what? The robot didn't see this little imperfection in the casting, so he didn't put a little extra effort into it. So they went through the whole process, and probably 50% of the parts that were done in the cell had to be redone by people on the bench. So in this case, the idea of robotic finishing didn't work, right? Because of that effort that a person can do. So they were stuck. And then they said, every time we want to add productivity, we have to have a room half the size with a robot, and we don't get any more than a person out of their productivity. So they were in a pickle. So what we did was we worked on drag finishing operations. So we mounted a bunch of parts. We took the right angle. We mounted parts, and we rotated them through a mass of media. And we did this 3 times and came up with a solution that was adopted by almost everybody in the world. Then we went further and said, okay, let's do a polishing operation. Let's improve it by taking a robot and getting better manipulation on a part, better manipulation with regards to the polishing media, and let's polish it faster this way. So that was another generation. Then we said, let's go back and let's take the robotic out of it, and let's take the vertical drag finish where you have to mount pieces on an arbor, and let's do one piece at a time, 10 times faster, and then go on to the next operation. So this was the third option of automating that polishing process. Another part you may recognize, so this is a gun barrel. This gun barrel is made out of an assembly of 2 different machined parts, which had 2 different surfaces. And prior to the coating process, those surfaces had to be blended to be the same, so that you would get the same look after the coating was done. So we developed, our first intent was a drag finisher, but we ran into a problem with vertical drag finisher because the part was too long, and you would get a variation in the finish. So we took a vertical drag finisher and we laid it down, and we made what we call a horizontal drag finisher. So now we're able to load parts in the full length and get an even flow across the product. And I don't know why it's not playing. Excuse for the okay, well, anyhow, this is laid out, the parts are in here, they're inside the media, and they rotate through a mass of media, and they rotate on their own axis themselves. So that was an automation process. So this is a disc that blades are mounted in for aircraft engines, and you see this pattern along that's broached in along the edge. We call it a Christmas tree pattern. And so this came off of a very extensive broaching machine, automated broaching machine, and a person sat there with files and had to file around all of those edges. So what we did was, this is called a reverse drag finisher. So we mounted the part on the drag finisher, and then we rotate the part through the media while we're turning it and while we're orientating it. And so this went from, I believe it was a 7-hour deburring process, to the person's actual time on the product was probably about 5 minutes. So that's, again, a different way of automating. Another product that's done on a CNC lathe, and it has to be, the machining lines had to be removed from it. It had to go into an anodizing process, so surface prep had to be done on it. So again, another horizontal drag process. Parts are taken from the lathe, lathe finish. What was being done before was going to a belt sander individually. Instead, now we go and we put it into a holding fixture, and then we rotate the parts. And another thing that was done, added to this to take it a little bit away from what we call mass finishing, taking 10 parts and finishing it, is we program the machine to have a tack time. So for every 7 minutes that a piece came out of a CNC machine, this part would be done, one part at a time, 7 minutes, 7 minutes. So an operator puts one in, takes one out, puts one in, takes one out. So that's another way of automating. Another process for automating. Couple of processes for automating gun barrels. We're mounting them on a drag finisher, or we're putting them on a disc finisher. We're honing the ramp of the bullet ramp here automatically. Same thing, multiple operations. I'm running out of time, so I'm going to hustle. Taking the polishing, 3 polishing operations, 3 steps of polishing a hip replacement. That's done in a barrel finisher. Automating the removal of powder on a mass of parts. And another way of automating that I think I should mention also is not only the actual process of doing the finishing operation, but also setting up cellular operations, which is a way of increasing your productivity. So here's 2 parts to a pistol, and the setup was to come from the machining center to a high energy disc finisher for the frames and the slides, and then to go to a cleaning operation, and then to go to a blasting operation, and then to go to a laser operation. So not only automating a system, but also automating a setup within your factory. Here's another one set up for automating and putting in line. So multiple steps are being done, and then rinsing and going on to another operation. So those are cellular setups that can be designed based around your company culture. So, quick time, anybody? I have cards up here, and a booth number is on it. If you want to come and see me, I'll be there the rest of the day. Anybody have any questions right now? Okay, so this is what you have to think about when you want to automate. These are the things that you have to outline before you say, hey, I want to automate this process. And then the bottom line is partner with a supplier who knows about manufacturing. Because it's not only the finishing operation, they have to understand what you go through as a manufacturer. Be careful when you choose automation that your company has an internal maintenance level to handle that automated equipment. Think about system duplicity. What happens if that system goes down? What do I do? And sometimes what sounds like a real good idea may not be so good. So be careful of those things when you start talking about automation. Now here's a question. Did anybody get a tool for their tool belt? Anybody? Yeah, you got a tool? All right, couple of tools out there. Good. Thank you very much. And now before we go, just a little bit of a fun tip for you. So this picture on the left is my nephew, and he's holding one of Robert Kraft's Super Bowl trophies from the Patriots. And the cool thing is that they came to us for the polishing and the plating of their giveaway Super Bowl replicas. So everybody on the team gets a Super Bowl replica along with Mr. Kraft's friends. So we got to work on that project for him for a couple of times. And then on the right is my son as a young boy, and he's on our coffee table holding the Kentucky Derby trophy. Solid gold, molded, metal spun, polished, and finished. We made the trophy for about 3 or 4 years for Tiffany's for the Kentucky Derby. So we get to see a lot of cool things. These are a couple that go back to show how archaic I am. So with that said, thank you very much. If you want, I'll be hanging around. There's a couple of parts up here. If anybody wants to come and take a look at them, I have my cards up here. So thanks again. Hope you go home with a tool.